Okay, so this is 7.2. Okay, before we get started in 7.2, let's do a quick review of 7.1. So for 7.1, we had these things called valence electrons. What are valence electrons? What are valence electrons? The electrons that are going to be on the outer shell. So if you recall, everything that is in the same group has the same number of valence electrons. On your chart, you had just a real quick something like this, and then we had like a 1, 2, and then over here you had 13, 14, 15, 16, 17, and 18. Okay, so everything that was in group 1 has how many valence electrons? It had 1 valence electron. Everything in group 2 had how many valence electrons? 2 valence electrons. Everything in group 13 has what? 3. No, it's 3 valence electrons. So remember, when you're looking at these group numbers over here, what you're supposed to do is you're supposed to ignore the one that's in front. And so everything in this group has 3 valence electrons. Everything in group 14 has 4. Everything in group 15 has 5 valence electrons. Everything in group 16 has 6 valence electrons. Everything in group 7 has how many? 7 valence electrons. And everything in group 18 has 8 valence electrons, except for which one? Your helium, which has how many? Helium only has 2 valence electrons. Okay, guys, if y'all aren't going to be serious, yes, you're about to lose it. Because I can hear the answers as far as the jokers out there who are throwing out wrong answers on purpose. All right. Okay, so those are your valence electrons. Now, if you were asked to draw a Lewis dot structure, let's say for potassium, which is in group 1, what would you do? Put 1 dot, because it's going to be the valence electrons that are put on here for a Lewis dot structure. Anything diagram, all right, it's going to be 1 dot. What was the rule? If you have multiple dots, let's say like phosphorus is in group 15, so it has how many valence electrons? What do I do before I start pairing them up? You put what? 1 dot on each side first, and then you start pairing them up, okay? The reason that you need to do this is because the ones that are by themselves are the ones that are going to be the ones used to pair. So those are the ones that are actually used in the reactions as far as making compounds. So phosphorus being able to interact with something else depends on which valence electrons are still alone because they want a partner, okay? Trying to get the electron configuration of a noble gas, which means they need a full outer shell. In this case, would need all 8, okay? One other thing we had talked about, so if this has 5 valence electrons on here, and what it is trying to do is get the configuration of a noble gas, it's either going to need to lose electrons or gain electrons. Lose all the electrons that are around it so that this outer shell disappears and the new outer shell is full, or we need to put dots around here until we have all 8, okay? What would this do? It could either lose how many valence electrons or gain how many?
3.
Which one is it going to do?
3 gain.
Gain 3, because it's the smallest number. All right, so if it's going to gain 3 electrons, excuse me. If it's going to gain 3 electrons, then when I put a charge on there, it's got 3, it did 3 something. What is the charge going to be? It's going to be negative or positive. Think about it. It's got 3 extra electrons. It's going to be more negative, so it's going to be a negative 3. Okay? So that's just a review of the 7.1. So let's go ahead and take a look at 7.2. All right, so 7.2 is now we're actually looking at the bonding that's going to take place. 7.1 was you need to learn what the valence electrons are. They are responsible for bonding. And now we're going to be looking at the different bonding that takes place. Specifically, what we're looking at is called ionic bonding. There's 2 types of bonds we're going to be looking at. You have ionic bond and you have covalent bonds. Chapter 7 is all about ionic bonds, okay? Ionic bonds So you have this, we're going to put it down here, is specifically between metals and non-metals. So students know atoms combine to form molecules by sharing electrons to form covalent or metallic bonds, or by exchanging electrons to form ionic bonds. And students know salt crystals, like sodium chloride, NaCl, are repeating patterns of positive and negative ions held together by electrostatic attraction. That has to do with charges, electrostatic attraction between positive and negative charges. Okay, so as far as your bonds, bonds are forces that hold groups of atoms together and make them function as a unit. Bonds, it holds them together and makes them function as a unit. Kind of like you gluing stuff in your notebook, right? Yeah. It becomes part of the notebook. All right, so specifically, your ionic bonds. Okay, ionic bonds, they are between, they form between metals and non-metals. So this is a metal-non-metal bond. Where are metalloids located, or semi-metals? Where are they located on your periodic table? Metalloids, where are they located on the periodic table? On the staircase. Where are the non-metals in relation to the metalloids?
On the right.
On the right. Okay, and where are the metals located? To the left and the bottom, so all the transition and intertransition metals as well as everything else. Okay, so when you see an ionic bond is going to be between a metal and a non-metal, okay? And this has to do with a transfer of electrons. Okay, so anytime electrons are being transferred, it's an ionic bond, and that is only going to happen if you have a metal to non-metal bond. It's a metal to non-metal bond. Okay, so just really quickly. So when we say transfer electron, that has to do with give and take relationship. Something is going to give up electrons, or what we said as far as when we're looking at the electron dot structure, is going to lose electrons, and something is going to take the electrons from it, which means it's going to gain electrons, right? So you're going to have something with a positive charge and something else with a negative charge. What happens when you put a positive and a negative together?
Cancel out.
Okay, but as far as do they want to repel or do they want to, they attract. So when one gives up electrons, becoming positive, and another atom picks up those electrons, becoming negative, they now have a positive and negative charge. They are attracted to each other, they stick, they bond together. Okay, that's what's happening there. Okay, so looking at this, take a look at the periodic table. We have, here's our staircase, non-metals over here, metals all over here. You do not include your noble gases because noble gases are the most stable and they generally do not react. They will not form bonds with other things, all right? So if you're asked about bonding in noble gases do not form bonds with anything else, okay? So you won't find them mixed. Non-metal to metal. So if I'm pointing at something like this and I say, what kind of bond happens between magnesium and oxygen? What would the answer be? What kind of bonding happens? Starts with an I. Ionic, because it's a metal to a non-metal, all right? So automatically, you know that's anytime you point to, okay, what is iron and iodine? What kind of bond would that be? That would be ionic. What kind of bond between lithium and nitrogen? That would be ionic bond because it's a metal to a non-metal, okay? Your next one, your covalent bond, is between, this is a non-metal to non-metal bond, non-metal to non-metal bond. And this is where electrons are shared We'll talk about this more when we get into chapter 8. Okay, chapter 8 is on covalent bonds. What I do want you to do today is just be able to recognize if it's an ionic bond or a covalent bond. Anyone still need it?
No.
Okay, so nonmetal is, I'm sorry, covalent bond is a nonmetal to a nonmetal. So that means if we're putting anything this to this, nonmetal to nonmetals, what kind of bond? What is it? Okay, I want everybody to participate. What if I say this to this? Ionic, look at where we're going. This is, I said this to this. Non-metal to metal is what kind? Ionic. All right. This and this. Covalent. This one. This one. Covalent. This one. This one. Ionic. Okay, make sure that you are able to do that. Everything over here is a what?
Metal.
Metal. These over here are, and along the staircase, metalloids. These are called what? This group specifically? Noble gases. Do they react with anything? Okay, so I should never see anything. I shouldn't see an argon bonded to anything else. Okay, noble gases do not react. All right, next one down. Okay, octet rule. Octet had to do with what? Octa. Okay, so octet rule. Okay, ionic compounds form so that each atom, by gaining or losing electrons, has an octet of electrons. In its highest occupied energy level. Metals lose electrons. To form positively charged atoms, cations, sorry, to form positively charged cations. Remember, atoms, that word's only used if it's neutral. Once it has lost or gained electrons, it's going to become an ion, either a cation or an anion. Nonmetals gain electrons to form negatively charged anions. Okay, so let's look at the next part down. It says sodium. Sodium has how many valence electrons? Here's sodium. Sorry, there's not sodium. Here's sodium. How many valence electrons does it have? It has, it's in group 1, it has 1 valence electron. 1. Okay. Chlorine, right here.
7.
Group 17, it has 7 valence electrons. All right, so it says an electron is transferred gives each an octet. So let's look at the electron configuration for sodium. I'm going to write out the electron configuration. It is, we need 11 electrons. It's 1s2, 2s2, 2p6, and 3s1. Chlorine. Take a look at chlorine. Can anyone tell me, looking at chlorine, take a look at chlorine. Can you tell me what it's going to end with? What's the last thing I'm going to write for chlorine?
2p5.
Okay, as far as an electron configuration, what would it be? Chlorine's right here. Chlorine's right here. It is going to be a P5. No. Is it? No.
P7.
This is P7 because this is 8, right? P1, 2, 3, 4, 5. What did we say? It is P5. What did I just say? Anyway, P1, P2, P3, P4, P5, P6. Chlorine is a P5. What level is it on? 3. So we're going to end in a 3P5. So we're going to write this all the way up to 3P5, which is going to be a 1S2, 2S2, 2P6, 3S2, and a 3P5. Okay, so looking at this, what is the outer level for sodium? What level is the outer level? 3S1. So how many electrons on the outer level 3, and then how many electrons on the outer level?
1.
It only has 1. Outer level for chlorine is level 3. How many electrons on level 3? You have an S3, S2, and a 3P5. These are both level 3. So 2 plus 5 is? So this has 7 valence electrons. This has 1 valence electron. Remember that the whole point is they want to be like noble gases. They want to have their outer shell full. How many more does this one need in order to be full? It needs to gain 1, because if it becomes a 3P6, then 2 plus 6 is 8, right?
Yeah.
This one, we would need to have to add 7 more electrons, or what happens if we get rid of that one? Then it's full. Look at the outer level. It has 2 plus 6, and now has 8, right?
Yeah.
So that's why they're going to do that. That's why this gives up or loses 1 electron, and that one is going to gain 1 electron. So what happens is this one is going to be added to this, okay? So that we end up with your Na. Your Na's new configuration is going to be 1s2, 2s2, 2p6. And your chlorine is going to be 1s2, 2s2, 2p6, 3s2, then what? 3p6. Okay, are these still neutral then? Are these neutral? This one lost an electron. What does it have more of? It has more protons, so that's why it becomes a +1. This one, on the other hand, gained an electron. It picked up an extra electron. So what's its charge going to be? -1. And what do we just say? If you have a positive and negative that are close together, what do? They end up being attracted. They bond to each other.
Yeah.
Okay, so you're going to end up with NaCl. Net charge on the compound must be 0. Whoever's phone that is.
Sorry.
Anyone need it? Raise your hand. Okay, next page. All right, let's go to the next page. I'm actually not going to have you Okay, so if you were doing models, atomic models, the way that you would see this is, let's say for sodium. Sodium has how many protons? It has 11 protons, so I'm going to put 11. And it has, is there a problem? All right, and then as far as the number of neutrons, since the atomic mass is 23, would be 12 neutrons. I'm just gonna put a little O up there for neutral. Okay, so the nucleus here is actually drawn a lot bigger than it normally is. How many shells does sodium have?
2, 3.
It's 3. So 1, 2, 3. And then it has 2 on its, this is level 1, 2 electrons. It has 8 on the second. 1, 2, 3, 4, 5, 6, 7, 8, just so you know what it looks like, and then you have 1 there. As far as your chlorine is 17 and 19, yes.
Does that say 11 PT?
11 P protons positive, and then 12 neutrons. And then chlorine has 17 protons, and how many neutrons? It needs to add up to 36.
18. 36 or 19?
19? No, 35, sorry, so 18. 17 protons, you were right the first time. Okay, so 17 protons and then 18 neutrons for this one. It is still a level 3. 1, 2, 3. So it has 2 electrons on the first level. 8, 3, 4, 5, 6. And then we have, on the outer level, there are 7. So if you see, we just said what's going to happen is this going to lose 1, and this is going to gain 1. So the way if you see anything that looks like this, where it looks like there's an electron being transferred, that shows a transfer, then that represents ionic bonding. Okay, when you see a transfer of electrons, that is an ionic bond that's being formed. Ionic bond. Okay. 17, was there a question? 17 protons in the chlorine, 18 neutrons. 18 neutrons. Okay, so with dot, sodium has how many dots? Valence electrons. And then chlorine would have how many? So how would I show a transfer of electrons? Same thing, arrow over. Shows 1 electron being moved. All right, again, ionic bond. So what if you don't have something quite that easy? The whole point is when they're bonding, they're trying to get the configuration of a noble gas, but we still want, when we're done with the bonding, we want it to go back to neutral, okay? So when you're done, the whole compound, everything put together, has got to be neutral, right? So in this one, it was just a 1-to-1. This one becomes a +1. This one becomes a -1. When you put a +1 and a -1 together, what's 1 minus 1? What's 1 minus 1? It's 0. It's going to be neutral, right? So the charges cancel each other out. So let's look at something like magnesium chloride. And we're just going to go ahead and do this with looking at the charges on each of these. So magnesium chloride. Magnesium, what's the symbol for magnesium? Mg. And I'm going to put some room between these. Magnesium is right here. Has how many valence electrons? How many valence electrons? Has 2 outer shell electrons. Okay, I'm going to leave some room. Let's look at chlorine. Chloride comes from chlorine. right here. How many valence electrons does it have? This is 7. Okay, so let's go through the whole lose and gain 1 electron. Is this going to lose or gain electrons? Magnesium is going to lose or gain? Lose how many? Lose 2 electrons, which means its charge is going to become, as an ion, it's going to be Mg what? Positive 2, good, because it now has 2 more protons than it has electrons. What is the chlorine going to do? Gain 1, so it's going to, oh, that was gain 1 electron. So what is its charge going to be? Good, -1. Okay, now I have a negative and I have positive. They're going to attract to each other. But does 2 minus 1 equal 0?
Nope.
So what do you need more of? You need more negatives. This is the way I want you to think about doing this. Okay. So off on the side, I'm going to put this Mg. Think of it as a math problem. Mg plus 2. And I've got the Cl -1, right? Think about this as a multiplication problem. What is the smallest number they will both multiply into? The smallest whole number they will both go into? 2 times something will make 1. What's the least, okay, math, at least this is the term that we used when I was growing up, least common multiple? No, not denominator, multiple. What's the smallest number they will both multiply into? 2. It is 2. So these are my positives over on this side. So my magnesium has to, I need it to multiply into a positive 2. These are my negatives. Chlorine's my negative, so I need a -2 over here because guess what? 2 minus 2 equals what?
0.
Okay, so the question is, what do I multiply this by? 2 times what equals 2? I need 1 magnesium. 1 times what equals 2? 1 times what? Ignore the signs. 1 times what equals 2? I need 2 chlorines. So now what you're going to do is the only thing that's important when you're writing these is you're not looking at the charges. You're looking at these numbers down here because this tells you how many of each, how many atoms of each you need. So this tells me I need 1 magnesium. Now when you're writing your symbols for this, if it's only one of them, you don't need to write it. The fact that I see the symbol there tells me there's only already 1 atom. So I don't need to write the 1. The Cl, there's 2. Okay, so this is my symbol for magnesium chloride. That's the answer. All right, so this is for ionic bonding only, not covalent bonding. Okay, we're gonna try this again. You're gonna have to do this on your homework. Okay, you're gonna have to be writing out the formulas. So let's try the next one. Any questions on that one? Anyone still need that one? Raise your hand. You're still copying? We'll do sodium oxide together, and then you're gonna have to do the last one on your own. All right, sodium. Sodium is Na. How many valence electrons?
1.
It's right here. 1 valence electron. So I'm gonna write it down with, here's my one valence electron. Oxide comes from what? What do you think oxide comes from? Something, no. You're adding stuff on. Oxide has to come from one of the elements here. Okay, so I will tell you, if it ends with an IDE, oxide, sulfide, phosphide, it is one of the non-metals. So where would the oxide come from? It comes from the oxygen. Okay, so oxygen, what's the valence electrons for oxygen? 6 valence electrons?
Yeah.
Focus. Okay, sodium, lose or gain?
Lose.
How many?
1.
Okay, and what will its charge be then? +1. Oxygen, lose or gain?
Gain.
How many?
2.
Charge?
-2.
All right, so that means over here I'm going to write my Na +1 and my O -2. What's the least common multiple? Smallest number they will both multiply into. 2? Okay, so this is going to be my +2 over here, and this is going to be my -2, which when added up will give me 0. One times what equals 2? And oxygen, 2 times what equals 2? So my symbol's going to be Na what?
2.
And that goes on the bottom.
And then O.
And then O. And again, since there's only one, I don't need to write it because I already see the symbol there. All right. Go ahead and try the next one. Do the next one. I'll put it up. Need it? Anyone still need this? Yes. 2 minus 2 equals 0. Aluminum is Al. Did I mention there's a quiz on this next class?
What?
Do this then.
Already?
Yes.
Oh.
Next class.
On Monday?
Wait, are you being you have black?
Oh, I'm not kidding.
Man, I'm gonna stress out with all the quiz.
Come on. Everybody should be working on this.
Those are 3-1.
Shooting stars.
Do aluminum sulfide. And go with the one in front. Look at the number 13. We're going to ignore the 1 in front of the 13. What's left? 3. That's how many this one. Draw a line from these cones. Okay, the other one was, it's aluminum sulfide. So what does sulfide come from? From the sulfur. Excuse me?
Can I get the green one? Okay.
They're up there.
We're good? We're not. Now we're back. The map. Like the
Yes. We're going to do pass out of class today, ladies and gentlemen. So on your way out the door, you're going to have your name, date, period on a piece of paper. I'm going to give you one of these. And on this little sheet of paper. So like we're doing mini quizzes. You're going to do them and you're going to give them to me on your way out the door. If it's not correct, you're going to sit down until you get it done. So please use your time right now to learn this. What's your valence electron? Y'all should have that. Sulfide, I told you, came from one of the non-metals. Work on there, yes. Okay, now what?
This is 6.
Okay, so 3 times 1 would be 3. 2 times 1 is that 3. 3 times 2 would be what? So you have 2 times 6 that would also make sense. Okay, so 6 Hold on. Y'all are gonna explain it to me. All right. Up here, everyone. Sure, aluminum. Here. Shh. Aluminum sulfide. Symbol for aluminum? Al. And the sulfide comes from which nonmetal? Sulfur, that's S. Okay, aluminum. How many valence electrons? Is it going to lose or gain electrons? Lose how many? Okay, so when I write the symbol Al, that means I'm going to have a 3 on here because it lost 3. Which one does it have more of now? Electrons or protons? Has more protons because it got rid of 3 electrons, so that's a positive 3. Sulfur has how many valence electrons? 6. So is it going to lose or gain? Gain how many? Okay, so sulfur with a 2 on it, and it gained electrons, it gained negative, so it has more negatives, so that's a negative 2. Take your charges over here. Okay, again, least common multiple. What will both these numbers multiply into? It's got to be the same number. Okay, so this is going to be my positive 6, and this is going to be the negative 6. Has to be the same number because they have to add up to 0. So 3 times what gives me 6?
2.
2 times what gives me 6? So it's Al2S3. Do not put any negatives or positives on them. This is not charges. This is how many atoms of each you need. Box your answer. Okay. All right. The next part here. Okay, what we're going to do is, shh. Now the way these things are named, listen up. When you have something like this, when you have a compound, the name is not, we don't call this aluminum sulfur. Okay, we're listening? When you have, this was your, and your positive, whatever had the positive charge on here, like this is the aluminum, is the one with the positive charge. The sulfur is the, or sulfide is the one with the negative on here. When you write your names like this, the one with the positive always goes in front, okay? The one that had the negative charge is always gonna be written in the back. The only thing is that, and the name that's in front, whatever this is, we don't change it. It stays the same. So aluminum is the positive one. It's going to stay aluminum. But the one that had the negative charge, you're going to change the ending. So sulfur, we change it. It's usually the first syllable, and then you add an IDE to the end. So sulfur becomes sulfide. Oxygen becomes oxide, IDE. Okay, so the ones that have the negative, the ones on the end with the negative, you get rid of their ending and put an IDE on it. Okay, so phosphorus becomes phosphide. There's only one, I think it's one, usually it's like one syllable, the first syllable, and then the IDE. So nitrogen is nitride. You got fluoride, chloride, bromide, oxide, nitride. Iodide is the only one because the iodine, it's iodide. So anyway, what will happen is I'm going to leave this blank for now. Go to this side because this is the ones that you need to, the endings change. Remember the front, the ones, the cations, the names are going to stay the same. So here for the nonmetals, you have fluorine. Write these down. Chlorine. FLU. FLUORINE. FLU. Chlorine. Bromine. Iodine. Oxygen. Sulfur. Nitrogen. And phosphorus. We skipped the front because the names aren't changing. All right, so what did I say for the fluorine? Fluorine becomes what? What does the name become? Fluor what? Chlorine becomes chloride, so IDE ending. You'll have to memorize these. You are not going to be given these. Oh, you already have the periodic table. You just need to remember to change the ending. So which ones do you need to change? Anyone still need it? Okay, so just testing you on names, because on your thing, you're not only gonna, on your homework, your assignment, you're not only going to have to write out the formulas like we just did, that practice, you're also gonna need to write the names. So if you see something like this, what would you call this? Oh, I heard it. K stands for what? Potassium, and BR stands for? It's bromine, but you're gonna change the ending, so it's gonna be, so this would be potassium bromide. IDE ending. What if you had something like that? Good, calcium fluoride. Let me give you one more. Hold on. Okay, I heard nitride. There you go. Barium. Barium nitride. It's barium, yes, got it. Good job. Okay, barium nitride, good guess. All right. So you're going to be writing the symbols, the formulas for the compounds. Okay. You're going to be writing the formulas, and you're going to be writing the names. Okay. So you have the assignment. Did I already pass up? I passed up the half sheet.
Yeah.
I'm going to hold off on the notes, so you are not doing all of this. You're not doing number 4, but you can do everything else except for number 4, since we haven't talked about the crystal lattice. Okay. You are going to do this on a separate sheet of paper, ladies and gentlemen. Okay, do it on a separate sheet of paper. Show your work. So I want to see, this is the minimum that I want to see. Okay, so like letter A. Actually, we already did, like we did it in the notes. Like we did it in the notes for those problems, those 3. That's how I want to see each one of them. If you just give me the formula and then write out the name, and I don't see how you got that, you will not get any credit. Okay? So show the work, show me the dots, show me the charges, show me your math, how you work it out. Okay? And then give me the final answer, box the formula, and then write the name next to it. So you are doing 1, and there's A through H, 2, and 3. Number three is a just circle. Okay? Number 3, or just pick one, A, B, C. You're just picking one of the answers. All right? Any questions on this? Nope. All right, we'll cover the rest of it next class.